So why 12 volt AC to DC voltages? Well, so first of all, 120 volt AC is wall plug and is dangerous. Circuit breakers are 20, maybe even 30 amperes in the home or in the laboratory. 120 volts is very high. As we see, 120 volts AC actually means that is 70% of the total swing, actually. So it's actually quite a lot voltage peak. So it's quite dangerous. And so that's why in this class, it's much safer to deal with the output of the transformer, which is 12 volts AC, although in reality that might be as high as 15 as we've seen, and 1,000 milliamps or 1 ampere maximum, as opposed to 20 or 30 off the wall. So everything we do is at least at this level. And this is easy to do by use of a transformer. And we'll talk a little bit about transformers later in the class, but suffice it to say it's a way of dropping down your voltage. But it's a much safer level to deal with. Remember last quarter in physics 110 we dealt with 9 volts DC all the time without any real safety issues. So that's when we do this, it's much safer. The problem is it's still AC. So we confront the problem is how to get from AC to DC. And the easiest idea and the first one we're going to look at, but not the one we're going to implement, we'll develop this idea, is to use, in our first try, something which is called a half-wave rectifier. It's a very simple circuit, and the idea is to use what we know about diodes as one-way valves of current. So this is our AC waveform. So this is a new symbol for us. It symbolizes an AC waveform. And we're just going to insert a diode. And then we'll go over to some place where we would attach our load. So we would eventually stick a load resistor in here. That is the thing that we actually want to power would be stuck across here. So since this is producing waveforms that go up and down, they would only the waveforms going in one direction would go through the diode. So we would no longer have something that goes up and down, but only has, say, positive voltages. Let's see how that works. Now, make some kind of temporary way to connect here we go. This might be a little better. You had cut one side long on purpose. There we go. Connect that AC power temporarily to a breadboard so we can experiment. That. Get the other side. There you go. Here, again, this is just temporary. We'll be soldering this in later to make sure they don't touch. Use a little bit of electrical tape. There we go. Okay, just a little temporary test setup here. And now I think we can safely bring in really gotta make sure these don't touch. There we go. So better. Okay. Great. Bring back our scope. Plug it in. Couple wires ready for probes. First, we'll check that we still have our AC waveform. Great. Now, break the circuit, and I'm going to grab one of the diodes. Now, the diodes that are in this package are very specific, and that they're a little bit bigger than a lot of the small signal diodes we've used before. Let's see, where are they on here? There it is. It's the 1N4007 diode, and we're just going to take one of them here at first. And bend it to go across. These can be a little hard to fit in circuit boards because they are thick wires. They're designed for handling quite large bits of power. And that's what our waveform is. Right? So here's our circuit. Our load is really now a very high resistance load that's internal to the scope, so it's many mega